Hi everybody and welcome to a new exciting series called Generating Melodies with RNN-LSTM. As the title gives away, you'll be learning how to generate melodies using long short-term memory networks. So in this video, I'm going to give you an overview of what you'll be learning of the whole series, and I'm going to cover from a very high level overview certain topics that will be needed throughout the series. Okay, so let's get started with what you'll learn. First of all, obviously, you'll learn how to build effective neural networks to generate melodies. And for doing that, we'll be using TensorFlow and Keras. So if you don't have any familiarity with Keras, this is a good opportunity for you to pick up a little bit of Keras and learn how to build, train, compile, and test LSTM networks. At the same time, given we're going to be handling melodies as time series data, so you'll get familiar with what time series data is and how to manipulate that and how to use that with deep learning techniques and algorithms. Then there's a whole other part which is more related to music. First of all, you're going to get a basic understanding of symbolic music representation. So you'll get familiar with MIDI, with Kern, with like the way like a musician writes their music. So, and this is going to be like fundamental because we'll need all of this information in order to pre-process the music that then we want to feed to our network. Then you're going to also get familiar with some basic music concepts like pitch, duration, notes, key, time signatures. And these again are all concepts that we'll need to be able to pre-process data and also to understand actually what we are doing with this data and what the neural network is learning, is picking up through the training process. And finally, obviously, you'll understand how to pre-process symbolic music. Now, let's take a look at the prerequisites. Now, if you're familiar with this channel, you know that I really don't do like beginner series. All of the stuff that I do are quite like advanced. So in order to follow along, you need to know how to like program in Python. So you should be an intermediate Python programmer. And it'd be great if you are already familiar with TensorFlow and Keras, but this is not strictly necessary because I'm gonna just like be covering like some of the basics. So I'll just like explain the code line by line. So even if you don't know Keras, that isn't that much of an issue. But if you want to really get started with Keras and deep learning, I have a whole series on that. So you should go and check that out, and it's gonna appear over here somewhere. Good. Okay, so throughout the series, we're gonna rely on a few tools and libraries. Obviously, we're gonna be using Keras and TensorFlow as our deep learning libraries of choice, and most of you by now, I'm sure, are already familiar with, but like Keras, it's a kind of like high level API that sits on top of TensorFlow, and TensorFlow is this machine learning library that's kind of like the industry standard right now. Then for processing symbolic music data, we're going to be using a Python library that's called Music21. This is a library that's used by computational musicologists, music theorists, and people in machine learning who are interested in dealing with symbolic music data. So, and finally, there's another tool that we'll be using. This is not a Python package or a library, but it's just a piece of software that's called MuseScore, and it's used for music notation. Now, if you want to install it, so you can go to the MuseScore website over here, and as you see down here, this is just a piece of software that enables you like to read symbolic scores like in music XML or MIDI and whatnot, and then you can like also like notate like your melodies. And yeah, it's a great tool and it's free. But if you have like other tools like Finale, for example, you can just like use that. So I'm going to be using this because it's free and it's also cross-platform. So it works with Mac, with Windows, and with Linux. Okay, so let's get started from some basic concepts. Many of you guys probably are already familiar with what a melody is, but everyone should have like the basics here. So I'm going to cover this from a very high level perspective. Now, there are many ways of defining a melody, but from an operational standpoint, like a very simple one is to say that a melody consists of a sequence of notes and rests. Over here, you have a nice melody notated in the notation that we usually use like in Western music. And this is the notation that has been used for hundreds of years now, right? And so here on the y-axis, you basically have pitch or like frequency. The higher you go, the higher the pitch. And on the x-axis, you have time. So we are notating pitches or musical events in time. Now, I've said that a melody is a sequence of notes and rests. Now, because of that, what we can do is take a melody and transform it into a time series. A time series is a data structure where you have samples that are taken at equally spaced position in time, right? So we can treat a melody as a time series, and the whole melody generation problem now becomes a time series prediction problem. So we basically want to predict the next sample in a time series. So in order to do that, first of all, we need to reduce all the notes to a given vocabulary of accepted musical events, like notes with different pitches and rests, which are moments of silence. For training our neural network, what we do is basically we pass in chunks of melodies, and then we ask the LSTM to predict the next notes in the melody. And we do this with a bunch of like chunks of melodies, and hopefully the LSTM is going to be able to understand what comes next in a melody just by looking at a lot of data. Good. So this is a very high level overview of how we're going to be training our model. But now you may be wondering, okay, but how do we generate music? Well, this is quite simple, because what we do here is we start with a seed melody. And these are like a few notes that we feed into the model. And then the model is going to give us a prediction. And the prediction is going to be the next predicted note in the melody. And you see it over here, like and with this red square, and then we take that, we append it to the initial seed, and we feed that once again to the model. And we expect yet another prediction from the model, which is the next note in the sequence in the melody, and then we'll take that, we'll append that to this guy over here, so the seed that we fed into the LSTM at this second iteration, and we continue. So we have a third iteration where we pass in the melody, and we now get another prediction which is for the next note. And so we can basically build a whole melody starting from seed just by doing going through this iterative process. And if we do this like enough times, we're basically gonna get a whole melody. Now I'm really simplifying like the process here, so you'll see when we'll deal into like the details that it's a little bit more complex than this, but this is like the high level understanding of what we'll be doing. Good. So now you may be wondering, but Valerio, why did you decide to use long short-term memory networks here? Well, the important thing to understand here is that melodies have long-term structural patterns. So they have patterns that repeat, they get slightly modified in the pitch content, or they get stretched or shrunk, right? And Let me give you an example of what I mean here. So I'm assuming that you know like this tune, which is like a very, very nice, simple tune called Twinkle Twinkle a Little Star. And let's analyze like this very simple melody here. So here we have the first phrase, and the phrase is a chunk of melody that's kind of self-contained and has some kind of closure. And this phrase here includes 4 different bars, right? Okay, so take a look at the 3rd row here. Basically, we are repeating the very same phrase that we had at the beginning of the piece, right? Okay, so now I'm not gonna sing this for you guys because unfortunately I can't really sing very well, but I'm gonna play this for you, and so you can listen to this for yourself. Okay, and by the way, here I'm using MuseScore so that you can also take a look at this piece of software that I'll be using to showcase melodies and to just like look at like different melodies. Okay, let's get started. Okay, so this is, oops. Okay, so that was the initial phrase, and now I'm just moving down here, and we'll hear this is the very same piece of music information, right? Okay, this sounds great. Okay, so we have like these patterns that are repeating, but this is like a quite high hierarchical level that's repeating. But we can also like go at a kind of like lower hierarchical level, and we can call this like a semi-phrase, and it has like a couple of bars in it, right? And it has this descendant movement, so the pitches are going down. Now, if you take a look at the melody here, so you'll notice that all of these other semi-phrases are basically the same as the original one here, right? The only difference here, for example, is that this semi-phrase is going up by a tone. We say, musically speaking, it's been transposed up a second. Right. Okay, so let's listen to this as well. So here we are over here. So let's listen to this. Good. It's basically the same idea, just transposed up. Okay, and back again. Nice. Okay, so this doesn't want to be like a lecture, like a music theory or anything, or musicology. But what I want you to understand is that like in music, we have this idea of like repetition, variation, and we have these musical structures that have like this long dependencies. Now, what LSTMs are really good at is to capture long-term temporal dependencies. So they are particularly good to kind of like recreate like these structures, these patterns, and these dependencies. So for this reason, LSTM have been extensively used for generating music, and specifically melodies, because they have this understanding, this memory capacity to handle like long chunks of melodies. Good. Okay, so now I hope you understand why I picked LSTMs, but still you may be asking, but why didn't you use GANs, or why didn't you pick, I don't know, variational autoencoders? And I would say, yeah, that is obviously like a great option as well, but I wanted to start with something that's more traditional, and we'll be discovering the way we can generate music with GANs and variational autoencoders in other series. So stay tuned for that. Good. Okay, so we said that we are going to need a music dataset for training the LSTM. And so what we're going to be using is a dataset that has a bunch of folk melodies. We are going to be using folk melodies because they are particularly simple, I would say. And the specific dataset that we'll be using is called ESAC, and it's a dataset that contains more than 5,000 songs from all over the world, really. This is the website for the ESAC dataset. So the long form of it is ESN Associative Code and Folk Song Database. So basically we're going to be using like a subset like this folk songs, and I'm going to be just like giving you like the link to this dataset down like in the description below. Okay, but this is like really a great dataset, and it's been used for generative purposes, but also just for analyzing folk songs. Because you have folk songs that come from all over the world, Europe, China, Africa, really everywhere. Okay. So what's next? So next time we're going to be looking into some very important music concepts, and we're going to be also looking into different types of symbolic music representation and understand how we're going to convert basic symbolic music representation into a format that's readable by our neural networks. So stay tuned for that. Obviously, some of you may know some of the things that I'll be covering, but still it could be like a nice refresher. That's great. So this is like all for today. I hope you really enjoyed like this kind of like introduction. And if you have any questions, as usual, leave them in the comment section below. And I hope I'll see you next time. Cheers.